Hi folks, Richard here, and today we've got part 2 of the Make Your Own CSGO C4 Game Prop video. And in today's video we're going to be talking about hardware. In other words, the 3D printing of the device, all the bits you need to make the device, where to get them from, how it was designed, how it all goes together, and all that good stuff. So what basically, I said in the previous video that there are going to be 3 parts to this video. I lied, actually. There's actually going to be 4 parts. 1, 2, 3, 4. First part was the introduction. Second part is this that you're watching now, which is going to be all about the hardware. The third part, the bit I was kind of missing, was the wiring. So we're going to have a separate video all about the wiring and all the electronics. That's quite a big subject, so we'll do that in its own video. And then part 4 will be the software, where I show you the source code, walk you through that, and you can get your hands on the bits that make it all tick. So let's get started. What I'm going to do, I'm just going to bring you into Fusion 360. Now, Fusion 360, which is here, is it's the CAD program that I use to design this in. It's my favorite CAD program, and it's what I use for any sort of mechanical parts that I want to design and 3D print. The good thing with Fusion 360 is that it's free. It's free for home use, free for hobby use, free for non-commercial use. And it's a full-blown, full sort of spec, commercial, professional quality CAD package. So the free license, the free personal use license, they do nerf a few features in that. They've removed a few features, probably things like really advanced computer-aided manufacturing things and things like that, but nothing that's going to stop you from using it as a really useful 3D design tool. So what I'm going to do, I'm going to show you around the 3D model, which you can see here, and we'll walk through this. We'll talk you through the design, and using this I can show you how it all goes together, where all the bits go, and all that good sort of stuff. So one of the first things you might notice with this, apart from the fact some of the bits are a little bit basic, like the screen doesn't have a display on it and things like that, there's a good reason for that, which we'll get onto later. One of the first things you might notice is this strange sort of tessellation over the actual C4 itself. The reason for that is that when I started designing this, I started out with 3 rectangular cubes. Can you have rectangular cubes? Maybe there's a better word for that. Anyway, 3 cubes that were then stretched out to make rectangular cubes. But they were dead square, dead flat edges. And Fusion 360 isn't really that great for organic modeling. As you can see, these need to have nice curved edges and little dings and bumps and sort of divisions between them and things. And although I'm sure Fusion 360 can do this, I just don't know how to do it in Fusion 360. So what I did was I pulled this out into Blender, and I used the sculpt tools in Blender just to kind of knock the edges off here, create a few little dents and dips, and make it look a little bit more like it's some sort of, I've never seen C4 for real, so I guess it's like some kind of putty or clay, something like that. So I imagine it's quite soft and pliable. So that was all pulled off into Blender, sculpted, pulled back in. That was a real game, to be honest. That was really, that's quite hard work getting that to do its thing. But that's another story. And so pulling it back in, we've got this kind of odd tessellated triangle thing on the go. So that's why it's like that. That's why it's not just like flat and square like the LCD panel. So if we look around this, you can see that we've got the sort of the enclosure here, which is going to be 3D printed. And on the front, we've got an LCD panel, and this is just a placeholder for the LCD panel that helps me to drill the holes. And again, we'll go into that in a moment. We've got the Arduino board modeled there on the front. And then on the front of the Arduino, we've got a keypad, again, fairly basic, just a basic blocked in shape to help me to locate things. And the missile switch isn't shown. So if you look at the actual model, obviously you've got a few extra bits. You've got a missile switch, and you've got some banana plugs and things that aren't in the 3D model. They don't really need to be. Things like the banana plugs, all you need on the 3D model is to know that there's a hole in the top of each one for each plug. and that all we needed to know really to model this was how what diameter the actual stem of the switch is. So looking over this, where do we start? Let's just take off the keypad for the moment. And you can see we've got an Arduino mounted to the front, and we'll remove that as well temporarily. So you can see that on the front there's some holes or some little standoffs here. It's hard. I know it's hard to see on this because of all the sort of tessellation. Let me just see if I can switch that off a second. We'll go visual style shaded. There you go. That might be easier to talk about for the minute. When you're modeling stuff like this, what's quite useful, you see we've got this Arduino model. That's something I got from a website called, I think it was GrabCAD. If we go over to our browser. So there's a website, grabcad.com/library. And here you can search for whatever you want. So if you search for Arduino Uno, it'll find models of Arduino Unos, and then you can find one, select one, and you can basically download the CAD files for it, and they do various formats. You can find a format that suits you. But the great thing with this is you can download what you're looking for. You can then pull it into Fusion 360, place it in your model, and then you can basically, you're not really worried about all the various components that are on there, but what you can do is you can project through the holes to get all the hole centers. So that's what I use that for, and it helps me line everything up. And again, with this in place, we could then look at adding in, say, the keypad. Now, for the keypad, I couldn't find anyone that had actually modeled the keypad that I used. So for this, I just knocked up a model myself with the dimensions of the keypad. And the main thing, again, is sort of things like knowing the thickness of it and where all the hole centers are. And then we can sort of use that to help us design it and place everything on the model. So that's the front bit. The LCD panel, again, that's just a mock-up there. The reason for that one really was not only the holes, we had to get the hole centers worked out. So again, it's a case of knocking up a basic model of the LCD geometry. We don't care about all the bits on the front, just really how thick the board is and where the holes are. And also, if we hide that, where is that hiding here? So that's LCD1. So if I remove that, you can see on the design here, we've got these two sort of blocks extruded out of the front panel. And the reason for that is that there's some various gubbins on the back of the LCD panel, things like pins sticking out. So we didn't want to fix it directly flat against the model. And these little standoffs just help us to space the LCD off the back a little bit. And then we can use the holes to line up. Now, for all the various holes, I will say there's various sort of hole sizes, various thread sizes for things. So if I just hide the LCD and hide the keypad and hide the Arduino again, we've got the holes for the Arduino and we've got the holes for the LCD, and there are some various other holes inside, which we'll look at when we get into that. What I've done, I've created a web page on the blog that is sort of supplemental to this whole design. So anytime you want extra information, like say you want to know what sort of thread sizes, what screw sizes to use, I'll give you a link to the website in a bit, but you can hop over to the website and we've got a page just for this. And excuse the video, that's just a placeholder till we get this video done. But on the website, we've got the parts list. So it's got the full parts list of all the bits you need. These are affiliate links to eBay, so I might earn a few pence if you click through and buy them from eBay. But the main thing really is to give you something you can click through. So you could click on to say, well, let's have a look at what we're talking about. The LCD display module. You can click that and that should take you to one in eBay. And at least you can then say, okay, yellow backlight and get rid of that. And you can at least see what I used. And if for no other reason than to sort of get all the part numbers and, make sure you're using the right kind of thing. But also what we've done as well, what we've got extra information. We'll come back to this bit in a while. Yada, yada. We've got a little section on screw threads. So there's a few little diagrams here that show you the size of the screws on the various bits. So on the front panel, this will tell you what screw sizes to use for the LCD and which to use for the Arduino. And also we'll cover the internals in a bit, but just be aware of that. It's a handy little resource you can go to there. Equally, what I will say as well is as we go through this series, if there's anything that I miss, anything I don't cover properly, or anything you want to see that I didn't cover, let me know. Let me know in the comments on the video, or head over to the blog, comment on the blog, and we can either get the extra information into another video, or I'll update the web page. So if you come up with any better ways of doing things or any extra info, as I say, let me know. We can keep the web page updated to cover all that info for you. So back over to Fusion 360. So that's kind of the front. Now, if you look on the front, just walking you around it a little bit as well, you can see on the side, we've got this extrusion here. So this is where the missile switch mounts. Easy enough. You just put the missile switch in and screw that on. The LCD panel, again, you would just screw that on with suitable size screws. There's a hole here. This is for the LED. There's a red-green flashing LED. Okay, so this is the red and green flashing LED, and that just basically pushes into that hole there. You'll see we've got some countersunk holes here. These are to screw the internals in. We'll go and look at that in a minute, but there's a tray inside that holds all the internal gubbins and things. So that's what these 4 countersunk holes are for. There's a couple of slots. Oh, let me just hide that back rear door. That's going to get in the way otherwise. You can see we've got these 2 long slots here. These are for cables to come through. So there are a number of cables that need to come from the inside out to the Arduino and the display and things. So that's what these long slots are for. This series of holes here, this is for the speaker. So there's speaker holes for the sound to come out of. There's a speaker behind that. And that's pretty much it for the front, as far as I remember. I don't think there's anything else we need to cover with that. So I'm just going to flip it around and let's put it back into sort of outline view, visible edges and shaded and stuff, because this will make life easier. So if we look around the back, you can see that I've just hidden the rear door there. So the rear door goes on. There'll be 6 screws here that hold the rear door on. They're M3 by 8 countersunk screws. Again, info about that on the website. So if we remove the rear door, there's a rear panel as well. Let's remove that so we can actually see inside better. So you can see this is the sort of the structure inside, and it probably looks a bit complicated at first, but it's not too bad when you get going. So what we'll do, we've got an electronics board here, which is this item. We'll cover that in video 3 when we do the electronics. So don't worry about that for now. You can do that later. So you can 3D print and make all of this and worry about this one later. So let's hide the electronics board for the moment. Why is that still showing? That's okay. Right. You can see there's a 9-volt battery inside. So the 9-volt battery means you can run it without mains power. So let's just hide the battery for a minute. And then we've got, in here, we've got a speaker. So you can see that's just modeled in black. And again, it's just a dummy sort of model so that I could get all the dimensions for making the actual model here. So we'll hide the speaker. And what we'll do, we'll just have a quick look at what the main parts are. So if I hide the front panel as well, so you can see that there's this kind of like internal cradle, or inner tray as I call it. This is kind of what holds all the parts, like the internal circuitry and all that kind of stuff, and the battery and things. That fits onto the front panel. So if we bring the front panel back in, you can see with the front panel there, and we just hide the bottom left and right for a moment. Let me hide, let's have a look. Let's hide all these parts just to declutter it a little bit. So you basically have the front panel, which you print out, 3D prints, and then you have the inner tray here, this assembly here, and we'll just hide the front panel again, just to give you a bit of clarity. So this is the inner tray, and this is probably the most complex thing to print. It's probably the thing that will take the longest to print as well. Just some notes on this in terms of sort of designing things for 3D print. You can see that there's a lot of free space in this. This is basically like an internal box. But here there's no bottom to it. That's all been sort of removed. Any sort of unnecessary plastic has been removed. The sides, the sides aren't just slabs of plastic. They've got these archways in. And the main reason for that is if you're 3D printing something, there's no point 3D printing parts you don't need. There's no point in printing this piece here as like a solid wall, because all it does is it means you're going to have a longer print time. It'll take longer to print and it'll be slower. It's quicker not to print this bit. The reason I use arches like this basically prints this way up. So when you're printing it, it'll print this way up on the printer. And if you use an arch, I found that you can print arches with no supports. So if this arch just went straight up and straight across, the 3D printer would have to sort of bridge all the way along here to actually get across. Whereas if you do an arch, you don't need to use any supports. If you tried to bridge that across, it could kind of do it, but it would probably fail. It would get stringy and horrible. And you'd have to then print with supports up here anyway. So rather than that, as I say, printing these arches, you don't need supports. It'll print in one with no supports. And as I say, the rest of it, this would have been all modelled as one solid piece, and all the holes and the the little doodahs and widgets would all have been moulded in and extruded originally with it as a box with a flat bottom and flat sides. And then after that, I would have gone round and just chomped out all these pieces. So it makes it look complicated. It looks kind of more complex than it really is. But that's just the reason for why it looks so kind of intricate, I suppose. There's no other real reason. Something else I'll mention as well is that you can see here we've got the battery clip. So if I bring the battery back in, you can see that's where the battery clips. So the battery sort of locates. Let me make this a bit bigger. The battery locates here. It's held in sort of position by these little walls here. And then there's two battery clips. Now, one of the things you'll find if you do CAD work, especially on a big monitor, I use a 27-inch monitor. And what you find is that when you're zoomed right in working on a model, you lose all sense of proportion. So if you look at this piece here, when I was modeling this, I'd probably been quite close in thinking, wow, this is really huge. On the screen, it's probably 20 millimeters wide on the screen as I'm looking at it. So you can make things way too small if you're not careful. Now, if we measure this, if we measure the actual finished size of this, if I hit the I button and then select this edge, you can see that's 1.5 millimeters thick, which is nothing. It's really tiny. So the reason I've realized that was a bad, or the reason I realized that was too thin was that when I'd actually made this and I was doing things, I'd sort of grab the device by this part here and snap it off. Because it prints vertically, the layer lines are horizontal. So it's like snapping off against the wood grain. It's very weak. So that's really the only sort of flaw in the design, I suppose, if there is one, is that that's a bit thin. So be careful with that when you print it. This will snap off really easily. It's okay if you're gentle with it, but if you're like me and you're a bit clumsy sometimes, you'll snap it off and super glue it back on again. So what I would do if I edited this design and changed it is I'd probably either make this thicker, or I'd just probably run a rib up the back, just put a web up here just to add a bit more support. So I thought I'd mention that because that's something that happens to me a lot when I'm designing things for 3D. Working on a big screen, it's easy to kind of make things way too fine because they look big on the screen, but in real life they might only be really, really tiny. So something to be aware of. Okay, so let's just take a few minutes to talk about the 3D printing and the fun part, really, I suppose, the bit where it actually turns into something real. So the 3D files you'll need are on the website. So if you go to the website, the web page, and you scroll down, and you scroll down, and you keep scrolling, you'll get to the 3D models. And here we've got the 3D models just in a viewer. You don't download them here, but this just gives you like a way of looking at the various components and seeing how they should look. So you can compare with these. Keep going, keep scrolling, and eventually you'll get to downloads. And here you can download a zip file of all the files that you'll need. And in the zip file, you'll find STL files, which is just the sort of the standard raw 3D files for each of the parts, as well as 3MF files. And the 3MF files are Cura slicer files. Now, if you use Cura slicer, then you can probably just download the 3MF files and tweak them to suit your own printer, because each printer is different. You'll be using different filaments. So you can tweak those settings to suit your own printer and filament desires. The STL files are there as raw files, and you can pull them into any slicer. So if you use a different type of slicer, you can use those. Now, what I'll do, if I take you over to Cura, I'll show you, I won't show you how to print every single thing here, but I'll just show you a few of the main parts, give you some ideas. Now, you can notice here I've got my filament is set to Apollo X. Now, I printed my CSGO C4 game prop with Apollo X filament, which is a modified ASA. The reason I chose that over something like PLA is mainly that there's a lot of work goes into making one of these. You take a lot of time on it, and because it was a gift for someone else, I wanted it to last a long time. I wanted it to, still be around in years to come. And much as I love printing with PLA, and PLA is a great filament, I really enjoy printing PLA, and it's nice and easy to print. The problem with PLA is it's just not very good at high temperature. So if you ever left this in a window on a warm sunny day, and it gets above sort of 45 degrees C, it's just going to warp. That's a problem. So I chose Apollo X because it's a more durable material. As I say, it's a modified ASA. So ASA is, I believe, a form of ABS. ABS is notoriously difficult to print because it shrinks a lot and it cracks. Apollo X is a low shrink sort of modified ABS, modified ASA. These days I actually use ASAX instead of Apollo X, so you don't have to use that. But that's why I use Apollo X anyway. It's just a choice, but you can print this out of whatever you prefer. So go ahead, print it out of PLA, it'll work fine. It just don't leave it in a hot place. So let's have a look at some of the settings here. As I say, you'll need to tweak the slicer settings for your own particular filament and printer and all the other things. But this is the front panel. And as you can see, we print it flat on the bed. So the back of it is nice and flat. That's really the main aim there. And if we go ahead and slice that, you can see it's saying it's an 11-hour, 33-minute job. The layer height's set to 0.1 in this particular slice. You might want to go with a small layer height, because if we preview this, and you'll see there's a lot of sort of salmon skin effect on the top from all the layers, because this is contoured and it's sort of sculpted. Horizontal layers don't print well on an FDM printer. So using a lower layer height will reduce this effect. It will make this a smoother transition, but it'll also mean it takes a long time to print. So it's up to you whether you want to have a rougher finish and a quicker print time, or you want to go for a 0.1 mil layer height and have this sort of effect. You'll notice as well I'm using a brim as a support. That'll be there somewhere. Build plate adhesion is set to brim. The reason I do that is because this is a modified ASA filament I've used, there's much more although it's supposed to be shrink free, it isn't. I mean, it will shrink a bit. So having a brim helps sort of hold the edges down flat against the bed so they don't warp up. That's one of the worst things with these filaments. But again, because we're printing this in very thin parts, we're not printing the whole box in one big chunk. Because it's thin, there's less chance for warping as well. So we used a brim to print it with. Other than that, it's pretty standard. The infill on this one is 10% infill, just a standard cubic infill. And the holes, I haven't done any sort of extra magic on the holes to make them thicker or anything like that. So that's that. I don't think there's anything more to add to this really. So let's have a look at one of the side panels. Again, pretty standard, printed flat to the bed, so you get a nice flat underneath on it. This is the one that has the little lug for the missile switch. And what we'll do is we'll preview that one. I've already sliced that, and we'll preview it. So same again, we're using a brim to help to reduce any kind of flexing on the edges. We don't want it to buckle up on the edges. Low layer height, so usual kind of deal. Now, looking at the inner tray, if I preview this one, this is actually only 7 hours and 56 minutes, so it's actually quicker to print this than it is to print the front panel. Helped in no small part for the fact that we've got so much air in this. Like I said, you don't need any supports with this. This will print perfectly fine this way up. And using these sort of archway supports, because they're circular effectively, it'll bridge fine. It'll basically print all the way up to here as an overhang, and it'll print very cleanly underneath as well. So I quite like using this technique, this way of printing things. So as you can see, I mentioned before about these pieces being quite weak. If we scroll down a little bit on the, you can see there's only 4 layers of plastic here on these, so they are quite weak. So you may want to strengthen those up if you so desire. But yeah, that's basically it for the 3D printing. Let's just talk about the sort of general construction of this as well. So we've got the inner tray, you've got the front panel that this screws onto. Now, with this, you've got these 4 countersunk holes here, 1, 2, 3, and 4. So you'd use an M3 by 8 countersunk screw to attach into these holes here. So this inner tray screws onto the front panel. Now, towards the end of the assembly process, you can actually glue this on as well if you want to, but don't glue this initially. There's a sort of bit of a sequence to how this all goes together. The sides, if you look at the top is just a flat piece, and that butts up against the front there. So if I toggle that on and off, you can see kind of where it goes. And you'll notice that on things like the top, there's no sort of locating tabs. If you built like a plastic model kit, they have little buttons and little locating tabs so that it helps things all line up. I didn't do that on this because for a very good reason, and that is that when you're printing, say, the front panel, if I hide the other things other than that, let me just get back to the front panel. You'll print this flat to the print bed, so you will print it this way up. So it'll print this way. And the reason for that is that we want the bottom to be nice and flat against the print bed. Now, if you put little tabs on here to locate the other parts, then you can no longer just print this straight on the print bed. You'd have to print supports, and this face would be really messy because it would have all the leftovers from the ends of the 3D printed support. So that's why they don't have tabs. And that makes the assembly a little bit tricky, because when you, say, attach the top, let's put it the right way up. There we go. Right, so when you attach the top, there's nowhere to locate it. It'll just sort of float around, and it'll just float around, and it's hard to locate. But there's a way around that, and I'll show you what that is. So if we bring in all the other sides, the top, bottom, left, and right, you can see we've got the 4 sort of side pieces. And then we have the inner tray, which is there. And we have a rear panel, which sort of goes on there, sort of surrounds that. And then we have a rear door that fits in the middle. So the way to assemble this, when you've printed all the parts out, the way to assemble it would be start with the front panel. So that's your starting point. And then get the inner tray, screw that onto the front panel. Don't glue it on, just screw it on for the moment. And then the next thing to do would be to actually screw on the rear door. So screw the rear door on. Oh, while we're on the subject of that as well, I'll mention it now while I remember. What I generally do with 3D printing is the holes in the 3D print are, let me just get rid of that. So this hole here, this is it's printed as the tapping hole. So it takes an M3 screw, but it's printed to be the tapping size for M3, so probably M2.5 millimeters or something like that. So, and it's not printed with a thread, it's just printed as a hole. So we don't model the thread in there. And what my rule of thumb really is anything M3 or larger, that is metric 3 millimeter diameter. Anything that diameter or larger, I'll actually tap it out using a tap and die. So I'd suggest on M3 stuff, use a tap and die to tap the thread before you put the screw in. Whereas on things like these little screw holes here that are M2.5, you can probably just self-tap the screw in there. So you get, say, a laptop screw or whatever, and you can just screw it straight in. The reason for tapping these out, one is it just makes a cleaner job of it, but also with 3D printing, if you just like try and get the normal screw to tap its own hole by screwing it in there, it's quite likely it's going to just crack the thread, crack the plastic. So you don't have to. You could probably just self-tap M3 screws in there, it'll be fine, but just bear that in mind. Right, so okay, so we're talking about how to assemble the thing. So we screw the inner tray onto the front panel. We screw the rear door on, so 6 screws to screw that on. The reason for that is if we do that, we can then just temporarily fit the rear panel. This will just fit over the door. If you look at the gap here, you can see that we've got like a little step here that the rear panel will locate onto. So at the moment, it's all just screwed together. The rear panel just rested over the top there. And then what you want to do is take one of the sides. Let's say we'll take the left side. Oh, no, let's take the right side. That's easier. So we'll take the right side. I'm just going to switch that tessellation off again as well, because that might be a bit confusing. So there we go. So what we do, if you do this, you can basically locate the side. You can put it in position very accurately, because you can sort of get it lined up with the edges. And so for the first edge, we're going to glue this together basically. So if we take the right side and the top, get them sort of held in place. And then what you want to do is just use a little bit of super glue, cyanoacrylate glue, CA glue, super glue. And just in here, with this all just sort of dry fitted together, just put a little tack of super glue here. It's like a little blob just to hold it in place. Because the thing with super glue, what you can't do with super glue is you can't, like, if you put it on two pieces of plastic and put them together, they'll just stick and that's it forever. You can't sort of maneuver them around. So you've got to get this in the right place before you glue it. So get this all nicely held all in the right place and just put a little blob of super glue here. If you've got some activator spray, use that. So in other words, you can get, you can buy activator spray for super glue. And with that, if you put super glue on something, spray activator spray on, it'll instantly set it literally straight away. And that's really useful for stuff like this. So anyway, tack a little bit of super glue here to hold this in place. When that's set, then you can come up here and just pop the top off because it's not glued. So we just remove that. Then you can come in here and you can put a little blob of, let me just get this in the right place. Another little blob of super glue here between the side and the front to tack it in place. And then when you've done that, you can sort of work your way around. You can do the same on the other side. You can just dry fit the top. Don't glue the top, but just rest the top on there. Get the other side panel, put that on, come down here, just tack the side onto the front. Don't tack it onto the back panel yet, just tack it onto the front. Again, pop up here, remove the top because you just rested it on there, and tack here with a little bit of super glue. So we're basically just sort of like tacking it all into place before we go for like the final glue up. So with the sides on, then what you can do is you can move the rear panel out of the way. You can take the rear door off if you want. You could take the inner tray out because that's just screwed on and not glued. And then you can get the top, put that on, get that lined up nicely, put a couple of little tacks of super glue in there. Then you can put the bottom on and just tack that on. Now with the bottom, bear in mind that there is another component here, which is the USB board standoff. So you're going to have to fit this component in here. So you probably want to do that before you go too far with gluing the bottom in, because what you don't want to do is get any glue. Let me just remove the front so you can see this. What you don't want to do is get any glue all in here where this, or on the side up here where this will interfere with it. So what you probably want to do is screw this in place next. There's a couple of holes here, so a couple of M3x8 countersunk screws. Screw this in place, and then you can then look at, let's get the front back in, because that would actually be fitted. And then you can look at getting some glue in there. I mean, you can glue things before you put this in, but just be aware if the glue gets everywhere, this might not fit anymore. You might have to remove some glue. So once you've got everything kind of tacked in place, then it's just a case really of going through and just putting a bead of super glue in the corners, and you can just run glue down the edges here, and that sort of firms it up. Something else that's useful for gluing this is I'd suggest using like medium gel super glue. So super glue sort of you can get it in like medium, thick, extra thin, different sort of viscosities. So use medium just for tacking it in, or if you want to put a big bead of super glue down the edge, you can use medium super glue for that. But what works really well for the rest of it is to get the extra thin super glue. It's like running as water. And with that, basically what you can do is you can just wick that down through all the edges, and it'll sort of run into all the seams, and it'll a capillary reaction will pull it along, and it will just go in there and flow in and weld it together really well. Okay, so before you go any further, don't glue any more parts just yet. Just hang fire for a moment. There's a few things we need to consider, which is that on the rear panel, we need to fit a USB socket and we need to fit a DC jack. Let me just show you those over on the actual real thing for a moment. Okay, so looking on the rear, you can see we've got a USB socket and we've got a DC jack. Now, both of these need to be fitted and wired in before you glue the back panel on. So the rear panel here, don't glue this on until you've sorted out these two components. And we'll talk a bit about that next. Let's talk about the DC jack. So the DC jack fits here in this hole, and the DC jack is actually optional. You don't have to fit one. If you wanted to only ever run this off batteries, you could just leave that out. And if you wanted to, you could probably mod the 3D file to remove that altogether. So you don't have to do that. If you do want to do it, then what you've got, let me just hide some of this other stuff. So let's just leave the rear panel only. And I'll hide that little USB board spacer. So this is the inside of the rear panel. What we've got is we've got a DC jack. Again, just basically a model of to get the sizes that we need. And you can see it's quite long. So we've got also a DC jack spacer, and this fits over. And in real life, this did actually meet up completely. There was no gap. But the idea of the spacer is basically you'd find screws then that would fit through this hole and screw into here. And that's your DC jack. But what you would need to do, because once you've glued this rear panel in place, you've no longer got any access to the back. So what you need to do is wire this up. Same for the USB socket. You need to wire these up before you glue the back on. So if you're going to fit a DC jack socket, you'll need to do that. Now, the DC jack socket, there are 3 connections on the back of your typical DC jack. You want one with a switch built in. That's quite typical. The reason for that is that when we come to wire it up, the battery power, so the power comes from the battery and it goes into one of the pins on the rear of the DC jack and then out of another one. And when there's no DC jack socket inserted, those pins are shorted from the battery. So the battery current can flow all the way through to the device. When you plug in a DC jack, though, the pins the battery are on get open circuited and it disconnects the battery. So that's really cool. You don't want to be putting current from the wall into an alkaline battery anyway. That would be bad news. So there are 3 wires to attach. So you want to attach the 3 wires. Just leave a decent length, leave sort of, I don't know, 200 mil, something like that, 20 centimeters of wire, whatever. So you've got the wires on there. Now, there is a slight complexity with the DC jack. Now, when I built this originally, the DC jack came from my stash of parts. So try as I might, I can't find where you could buy one of these DC jacks. So what I've done, we go back to the good old website again, and we scroll up here. You can see we've got a few drawings I've added to the website for you. And one of them is for the DC jack. So because I can't tell you where to get one, what I can do is give you the dimensions that I designed it to. So if you go to the website, you can see here, this tells you what size I use. So if you can find one, if you can go do some hunting and find someone that can sell you one of these, I'm sure they're readily available. I just couldn't find one. This will give you the information you need to go and find one that matches. And if you do, let us know in the comments below. Let us know where you can buy one of these and we'll add it to the web page for others. They can help them out as well then. So be aware of that. You're going to need to get that wired in before you can go ahead. And also let me just hide those DC jack parts. Also, you're going to need to improvise the USB socket on the back. Now with that, let me just bring the Arduino back. I want to see if they've actually modeled the USB port, and they have. Excellent. Right. Okay. Let me bring in also the other USB parts. We've got USB board and standoff, and let's bring in the bottom as well. There we go. Right. So to make this look more like the CSGO prop, what I did was I took the USB port off the Arduino. Now this is soldered on. You see there's a few little tags here and some solder pins. So basically desolder this and remove it from the Arduino. And then what we do is we relocate this down to a little custom made board down here. So this cube you're seeing here let me see if I can select that more easily. Can I just highlight that? No, that's the board. That's the body. Right. So this blue cube you're seeing here is this USB port that's been moved down. So we're basically relocating the USB port from here down to here. And to do that, we basically make up a little board. This is not a circuit board. This is just a piece of Vero board. So I've got some Vero board here. So piece of this is listed in the parts list on the website as well. So all you do is you basically, if you go over to the website, let's have a look at that. If you find the diagram for the socket assembly, USB-B socket assembly, this part of the drawing here, this square is the actual USB socket, and this piece here is the Vero board. And you can see we've got the dimensions, so 29.1 millimeters high by 16.9 millimeters wide. And there are two 3.4 millimeter holes there, about 3 mil would be fine. And they're just almost 5 millimeters in from the ends. So like I say, basically what we're going to do, we're going to take a piece of Vero board, just cut it to that size, take the USB socket that you removed from the Arduino, put it through the non-copper side, put it through there, and then solder the pins on here. So you solder the pins. Where all the pins go, you can see that the copper tracks run this way. What you'll need to basically make sure that you cut the pins to isolate each of the 4 pins for the USB connector so that you don't want to short them together. Then all we're going to do is drill a couple of holes in here. This lets us mount this over on the base of the enclosure. And then before you put it together, basically just get some Kynar wire. Kynar wire is just thin equipment wire. Again, it's listed in the parts list. You get some thin Kynar wire, just tack 4 pieces, say about sort of yay long. Tack them onto where the pins are, just blob them on with a bit of solder. So you've got the 4 wires coming off each of the USB pins. Well, 1 wire off each USB pin, but 4 wires in total. And those wires then go back into the same holes that those pins came out of on the Arduino board. So all we're doing effectively is extending the Arduino USB into the rear of the device. Okay, so before you can attach the rear panel, you'll need to cope with the USB, screw this in place. Again, I believe for that's just the M3, probably do M3 by 8 socket heads or countersunk screws on that. It won't really matter. But you need that in place. You need to get the DC jack fitted. And let me just get rid of the Arduino again. So hide that. And let's see where we are. So if I let's get all those parts back in again. So we've got the DC jack socket, the USB, we've got the USB board, and we'll just remove the rear panel for the moment. Just trying to sort of get this to look how you'll see it. So we'll get the front panel top left, right. So, okay, so you've prepared the USB port and the DC jack, the rear panel's ready to go on. So the next thing is to fit the inner tray. So the inner tray, you can just screw that on. Let me go back to the wireframe, not wireframe, but the shaded with visible edges only. There we go, that's easy as a C. What we're going to do, we're going to fit the inner tray. As I say, you can just screw that in place. If you wanted to glue it, you can. But again, just remember that with a super glue, it's got instant grab. So if you put super glue on the inner tray and you sort of put it in place, it's just going to stick wherever you put it. So if you don't get it lined up perfectly, you've had it really. You'll never get it off. So screwing that in is probably good enough. If you did want to glue it, maybe use a different glue. Maybe use PVA glue just to give it some stick, or a glue that's got more of a open time, a glue that's not going to set up quite so fast. So anyway, fit the inner tray, and then with that done, then what you can do is screw on the rear door. I would say do it this way, screw the rear door on, because this sort of helps you locate the back panel then. Then what you can do is put the rear panel on, and then you want to basically run a bead of extra thin super glue around the edge so that it sort of wicks in and glues that. And when that's in place, then you can remove the rear door and oh, there we go. Just lagged on me for a moment. You can remove the rear door, and then you could try and get a little bead of extra thin super glue in around here. Just go careful you don't kind of get it all over the place. That's the main thing. But on mine I did. I actually ran some glue under there as well, which sort of tightens it up quite well. So that's kind of it for assembly. Once you've done that, you can screw the rear door on, and there you go. You've got the whole sort of box is made and ready to go. From there, it's then a case of fitting out all the electronics. And as I say, we'll talk about the electronics in part 3, and we'll go over all the circuit boards and all the wiring and what wire goes to which pin and all that kind of stuff. And we'll talk more about the Arduino and where the Arduino goes and the LCD panel and all that kind of stuff. Well, congratulations if you've made it this far. You're now ready for some paint. So let's talk about how we did that. You've 3D printed the enclosure. You've got all the parts. You haven't fitted them on yet. You've just basically got the bare box. So the next thing is to get some paint on. So what I did for painting this was I basically masked off the USB socket and the DC jack. Just put some masking tape over those, and I mixed up some green paints and I airbrushed it. I've got an airbrush and compressor, so I used an airbrush to finish this. So just made a sort of dull green. On the seams between them, I just gave it a bit of black spray. I didn't try and get a sort of a realistic looking finish. You know, I mean, with this basically you're looking to make it look like a fairly sort of low poly game prop, not the real thing. The paint I used was Createx Wicked Color, which is a sort of fairly sort of standard airbrush paint. You could use any kind of acrylic paint on this. You could use Vallejo or whatever you prefer. You don't have to airbrush it. You could use car paint. You could use car spray paints. You could hand brush paint it using something like Games Workshop paints. They work really well. Or just print it in a sort of olive colored filament. You could just print it in the right color filament from the start and be done with it. So that was basically it for the painting. Now, with the labels, I will just show you what we've got with the labels. If we go back over to the website and scroll down the web page, scroll down the web page again until you get to the C4 labels. And here you can right click this image and save it, and then you can print out labels for the C4. Now, all I did with this, if I take you back over to the device itself, all I did for this was printed these out on just on an inkjet printer onto copy paper, printed them out, cut around them, scuffed them up a bit, tore them a bit, and then I glued them on. I think I used PVA glue to glue these on, just some sort of, you know, school glue kind of stuff. With the labels on there, then the whole lot had a coat of, I used AK Ultra Matte varnish, airbrushed or sprayed varnish over the whole thing, a matte varnish, just to seal the labels in so they don't peel off too easily. But you could use anything you like. You don't have to varnish it. I mean, I just chose to because I happen to have that in my sort of arsenal, as it were. The tape is just literally, it's literally authentic silver duct tape, gaffer tape, whatever you want to call it. It literally is just the sort of 2-inch wide stuff torn into 1-inch strips and just taped around. So that's genuine, authentic stuff there, which is pretty cool. Moving around the rest of the device a little bit, and we talk a bit about the assembly. The missile switch, that just basically screws through that little lug we made there. So there's a screw there. Clamp that down, and then you can see we've got some of the wires coming through one of the holes on the front to there. So we switch the power on and off. And as I say, we'll go through the wiring in part 3. The banana plugs. These are called banana plugs because the ends of them look a little bit like bananas, but I mean, you've got to be pretty blooming hungry to start seeing these as bananas, but there you go. Again, these are all in the parts list on the website, so you can see what I use for these. So the red, black, yellow banana leads, cut the other ends off, feed them through one of the slots underneath, and then inside there's a cable tie just to hold them together, and they're cut off inside, and that's that done. We got, as mentioned before, we got the flashing LED. That's just pushed in from the inside, and you can put a little dab of glue on the inside to hold that in place. The LCD screen, LCD panel, you're going to have to raid some sort of laptop screws or something. I can't remember what size screws these are, so again, I've got a link on the website that will tell you where you can get hold of various laptop screws. But yeah, these are just screwed in through the four corners, and that sits on the little standoffs we talked about, which are in there in the dark. You probably can't see on the camera. You see here we used a floppy disk drive cable for the LCD. So this is just torn off the side of a floppy disk drive cable. It looks really authentic to the game prop as well. And then that runs under the LCD and then loops over and is wired in there. And this actually would then go through one of the slots in the front of the case in the front panel to the inside. Equally, we've got another bit of floppy cable coming out to wire onto the keypad here. The Arduino is fitted with these little M3x8 button cap screws here. There's one there. And let's have a look. In fact, there's only that one holding it there. On here, I don't know if you can see this on the camera very well, but there's a little keypad standoff that you can print out. This screws onto the Arduino with those M3x8 button screws. So you can, sorry, I was in the way there. So this screws on here, and then it extends these holes over that line up with the keypad, and that's more M3x8 button screws to hold the keypad on. So the bottom of the keypad screws into this little 3D printed riser that we've made. On the front piece, there's no screw in here. I mean, at the end of the day, you know, this is meant to sort of be a representation of a kind of improvised explosive device, you know. So you've got artistic license to kind of, you know, you could just like tape this on if you wanted to, or just use string or something, you know, it doesn't have to be perfect. So there's no screw there because it doesn't need it. And then there's a longer screw here. Now there is a little standoff we've made here. So just there, because there's a gap between the Arduino and this piece here. This is part of the download. This is one of the 3D prints, this little spacer that goes in here. So if you wonder what that does, that's why there's that little spacer. So I don't know if you can see that okay on the screen there. You see there's a little lone wire here. I forget why I did that. It's probably because I just ran out of floppy disk drive cable, so I probably didn't have enough wire, so I just ran a little bit of Kynar wire from here up to somewhere on the LCD panel. So you don't have to repeat that. You can wire it however you like. Because like I said, don't get too bogged down in sort of how you do this. You know, it's okay to deviate from what I've got here. You don't have to like replicate it absolutely perfectly. But yeah, I think that sort of pretty much wraps up the construction of the device and the hardware. So now we can think about moving on to the next stage. Well, again, congratulations if you made it this far. By this point, you should be well on your way to having your own CSGO C4 game prop. By now, you should have all you need to get all the hardware up together. You should be able to 3D print the device, glue it together, and start getting all the hardware together. As I said, what we'll do on part 3, we'll talk about all the wiring and the electronics, and we'll get inside the box, and I'll give you a wiring schedule as to how it's wired up, and we'll talk in more detail about some of that. And then part 4, we'll look at the software and how all that goes together. So as I said, we've covered a lot of ground here. I may have missed things out. I'm not sure I've thought of everything that you need to know. So if you've got any questions, hit the comments below or head over to the webpage on the blog site and feel free to comment on there. You can also contact me on Twitter or the usual channels. So if you've got any questions, feel free to fire away. There's no such thing as a stupid question in this game. If you've got any suggestions or anything you can add, again, hit the comments. And if you do have any questions before the next video is out, then by all means ask them, and I'll see if I can get the answers to you in the next video. Or we'll certainly get it uploaded to the website. So if you find anything that's missing or there's anything you think we could do differently or change, again, we've got the website there so we can sort of keep all the changes live on there and keep it all fresh. So anyway, I really hope you've enjoyed that. I hope you have fun making your own CSGO C4 prop. And until next time, thanks for watching.